Welcome back. Lesson 2 of Unit 2, Exponents and Powers of 10. We're going to be able to explain patterns in the number of zeros when multiplying the powers of 10, use whole number exponents to denote powers of 10, and understand the place value system. Before we begin, we have some vocabulary that we would like to review. We have exponent, power of 10, and exponential notation. An exponent is a small elevated number used in exponential notation to indicate how many times a factor should be repeated. For example, 10 to the fourth power, the exponent is 4. You can see that it is smaller and it is raised. Power of 10, a whole number that can be written as a product of tens. For example, 100 is equal to 10 times 10. So the product of 10 times 10 is 100. It can be written as well as 10 to the second power or 10 squared. 100 is called the second power of 10, 10 to the second power, or 10 squared. Exponential notation, a way to show repeated multiplication by the same factor. For example, 10 to the third power is exponential notation for 10 times 10 times 10. Remember, you can always pause the video to write down and read these as well. So take a look at these number sentences. I had to fix this one right here because it was not showing up all the way, but we see 10 to the second power equals 10 times 10 equals 100. And 10 to the fifth power, this is another way of showing that exponent when you're typing. So later on when maybe you have to write a response on Canvas or something digitally, you can write this and then have that little arrow pointing up and then the number and that represents exponential notation. Well, we see we've got 10 times 10 times 10 times 10 times 10. And again, this cut off, we should have 5 zeros there. So let's go ahead and write those in for you. So we see that 10 to the fifth power is 10 times 10 times 10 times 10 times 10 equals 100,000. So again, right now, let's just look at these little raised numbers and looking at what we have in the number sentences themselves. What do you think those small raised numbers mean? Well, hopefully what you said to yourself is that the small raised number tells us how many times this base number is going to be multiplied. So we see 10 to the second power. I see 10 times 10. So I see 2 tens are being multiplied. Same thing down here. The 5. 1, 2, 3, 4, 5. It tells me 10 fives are being multiplied. I'm going to show you another little tip. We've got a 0 and a 0 in 100. We've got 2 tens, 2 zeros, and an exponent of 2. Well, 1, 2, 3, 4, 5. I have 5 zeros in 100,000, 5 tens, and an exponent of 5. The small raised number is called an exponent, and the number before the exponent is the base. The exponent tells how many times the base is multiplied. When the base is 10, the number is called a power of 10. Remember your recent work with standard notation and expanded form. Today, you will use powers of 10 to write numbers in exponential notation. Let's take a look at powers of 10. This is in the SRB. Remember, you can look at the SRB online on the Everyday Math website, but I have these pages here for you. Go ahead and pause the video now and read through this slide. Notice it says numbers like 10, 100, and 1,000 are called powers of 10. 100 can be written as 10 times 10 or 10 to the second power. That smaller number that's raised, like we said, is the exponent. And the normal number is called the base, the number before the exponent. This part down here, a number written using place value like 1000 is in standard notation. A number written with an exponent like 10 to the third is in exponential notation. This is also on page 68 in the student reference book. It's a chart that shows the powers of 10 from 10 through 1 billion. If you take a look, this column right here on the far left, the column here, has standard notation. We see we go from 10 to 100 all the way up to 1 billion. In the middle column, we have the products of 10. So we have the multiplication problems. We know that 10 is just 10. When we go to 100, it's 10 times 10. If we go all the way down to 1 billion, it's 10 times 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 10. One more time, times 10. And then finally, in the far right column is exponential notation. We know that we had 10, 10, and so that's just 10 to the first power. We talked about 10 to the second equals 100. And going all the way down to 1 billion, 10 to the ninth power. I'm going to take a moment and look. 10 to the ninth power tells me I should have 9 tens being multiplied. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 tens, and I have 9 zeros in the number 1 billion. So remember that each number is 10 times the number above it and 1/10 of the number below it. The number of zeros in a power of 10 written in standard notation is the same as the numbers of tens that are multiplied to give that product. The number of zeros in a power of 10 written in standard notation is equal to the exponent of that number when it is written in exponential notation. For example, 1 million has 6 zeros, so the exponent is 6. 1 million equals 10 to the 6th power. Open up your journal to page 41. And I already did this one for us. We're going to talk about it. So now all you need to do is fill in the blanks. So they already have in your book 10 to the 6th power. And we see that they wrote 1, 2, 3, 4, 5, 6. They wrote 6 tens and they are multiplying those, giving us an answer of 1 million in standard notation. So looking at the exponential notation column, I see I had written down, I'd put in there 10 to the 5th power. Well, looking at the exponent, I know that I should have 5 tens being multiplied, and that answer should have 5 zeros. Taking a look, 1, 2, 3, 4, 5. We have 5 tens, and then the answer is 100,000. And we can see we have 1, 2, 3, 4, 5 zeros in the number 100,000. This one's pretty large, so it kind of overflows into all the spots. But taking a look right here, 10 to the 8th power. How many 10s should I have being multiplied? That's right, I should have 8. So we have 1, 2, 3, 4, 5, 6, 7, and 8, giving us an answer of 100 million. 100 million. And we have 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. And one more example. We have 10 to the 3rd. So I see that I have 1, 2, 3 tens, giving me an answer of 1,000. Okay, so we have 1, 2, 3 zeros, and then we put our 1. 1,000. So when we look at this, it should be 3 times 10 to the 2nd power. Okay, so I'm going to go ahead and take a minute and I'm going to rewrite it for us so that we can see it better. 3 times 10 to the 2nd power. I know that I'm going to think about 3 times whatever this entire thing represents. Okay, and I know that when I'm looking at 10 to the 2nd power, I'm going to rewrite this. This is going to be the same as taking 3 times 100. 3 times 100 which gives us an answer of 300. So 3 times 10 to the second power is just like saying 3 times 100 and 300. So erase that for us. We can also take a number like this and turn it into a power of 10 number. I see that I have the number 65, so I'm going to write 65. And then I'm going to write times 10. Well, I know 65 times 10 is 650. So I'm going to say I've got 1, 2, 3, 4, 5, 6 zeros. So I know it's going to be 65 times 10 to the 6th power. Now it's your turn. I want you to, if you have closed your journal, open it back up to page 41, and you've got a couple pages that I want you to work on, and then you'll pause and you'll come back and check your work. So you'll see here, complete the number sentences. 3 times 10 to the second. They've given us the next step, 3 times 100. Okay, think about what that equals, and then write the standard. 7 times 10 to the 9th. Now they want you to write in what does 10 to the 9th equal and what does that altogether represent. Then on 3 and 4, they've only given you the exponential. You now need to do what do those mean? What do they equal? And then on 5, you need to write the exponential notation based on this right here that they've given us, using the information that you see in the video and then moving on to do those. On number 6, you need to use the answers from 1 through 5 to fill in the blanks. Okay, so you're going to figure out the numbers at the end of all these, which ones fill in the blank the best. So in the previous lesson, you learned about writing numbers in expanded form. Read the top of journal page 42 and think to yourself, what do you notice about the ways of writing numbers in expanded form? So here you have it. Numbers in expanded form are written as addition expressions showing the value of each digit. So you can see we've got 2,784. So we have 4 ones, 8 tens, 700s, 2,000s. Or you got 4, 80, 700, 2,000. Or 4 times 1, because it's in the ones place. 8 times 10, 7 times 100, 2 times 1,000. And we can move that further even one more time. 4 times 10 to the 0 power, because it is the ones, so there's no 0. 8 times 10 to the first, 7 times 10 to the second, and 2 times 10 to the third, using those zeros and those exponents together. So 2,784 can be written in expanded form in different ways. As an addition expression, it's simply 2,000 plus 700 plus 80 plus 4. As the sum of multiplication expressions involving powers of 10, we've got 2 times 1,000 plus 7 times 100 plus 8 times 10 plus 4 times 1. And then we can even move it further and use powers of 10, 2 times 10 to the third, plus 7 times 10 to the second, plus 8 times 10 to the first, plus 4 times 10 to the 0 power. 2,784 can also be written in a few other ways. Okay. So we can, again, use it as an addition expression, the multiplication, and the multiplication of expressions with powers of 10. So the multiplication expressions shows the value of each digit as the product of two factors. One of them, a power of 10, written in standard form. So you see 1,000, 100, 10. And then when we're moving on to exponents, it's similar to the second one, but it shows it in power of 10. Okay, so here you can see 1,000 can be rewritten as 10 to the third. That's not what I wanted. Here we go. Okay, so now moving on to page 42, we have write 6,125 in expanded form, and then write it as a multiplication expression, and then using the powers of 10. Number 2, 12 times 10 to the 5th power and 4 times 10 to the 8th. And then number 3, write each number using exponential notation. So we've got 30,000 and then we've got 4,200,000. So pause your video, rewind if you need to see any of the examples again, and complete page 41 and 42. Taking a look at 1 through 5 on page 41, feel free to pause the video so you can see these answers. But we can see that number 1 is 300, 2 is 7 billion, 3 is 30,000, 4 is 25,000, and for number 5, it's a little bit different. We had 93 times 10 to the 6th power, or 93 times 1 million. So using the numbers from 1 through 5, or your answers from 1 through 5, on problem number 6, the best way to answer these would be, say, the distance from the sun to the earth is about 93 times 10 to the 6th, or 93 billion miles. The Statue of Liberty is about 3 times 10 to the 2nd power, or 300 feet tall. In 2014, the population of Earth was about 7 billion, or 7 times 10 to the 9th. If you walked around Earth's equator, you would walk about 25 times 10 to the 3rd, or 25,000 miles. And finally, Mount Everest, the highest mountain on Earth, is about 3 times 10 to the 4th power, or 30,000 feet high. And finally, on page 42, number 1, you've got 6,000 times, let me start that over. 6,000 plus 100 plus 20 plus 5. Then you can see that it goes to 6 times 1,000 plus 1 times 100 plus 2 times 10 plus 5 times 1. And then in expanded form as in exponents, powers of 10, 6 times 10 to the 3rd plus 1 times 10 to the 2nd plus 2 times 10 to the 1st plus 5 times 10 to the 0 power. Again, remember that when you're using a number in the ones place, it's 10 to the 0 power. We can still write it as an exponent of 10 with powers of 10. Number 2, 12 times 10 to the 5th power is 1,200,000. B, 4 times 10 to the 8th power is 400 million. And then 3, 30,000 can be written as 3 times 10 to the 4th. And then 4,200,000 can be written as 42 times 10 to the 5th. We keep it as 42, and then we can see that we've got 1, 2, 3, 4, 5 zeros after the 42. Great work. And now what you should do is check out your 2.2 independent work on Canvas. Remember that today we were able to see those patterns in the number of zeros when multiplying by powers of 10. We're using those whole number exponents to denote the powers of 10, and also continuing understanding that place value system.